Hi, and welcome to week 5, multiplication of whole numbers. I hope that you are starting to think about the midterm and what that's going to look like, so you should make sure your notes are well organized and you're starting to study. So this week, we're still going to hopefully talk to our classmates and start studying with them. You have a flip grid this week, so that's always fun to see our faces. We're going to do investigating multiplication and division situations. Even though we really do division more next week, multiplication and division are connected, so we're going to talk about both of them first. We're going to talk about different types of multiplication and division word problems, and then how students make sense of equal groups. And we'll be really focusing on MP2, reason abstractly and quantitatively, MP4, model with mathematics, MP6, attend to precision, and MP7, look for and make use of structure. So here's a warm-up. This is flashback to last week. So use a non-traditional strategy to solve this problem. Be sure to record with proper notation and explain your strategy. So show how it could be used in the problem 413 minus 285. So pause the video here, try maybe one or two strategies, make sure you know the name of it and you could describe how you're doing it. And then press play on the video again and you'll see some of the ways we could do it on the next part. So here's some non-traditional ways. You could use counting up, you could use counting down, those are both with number line strategies. You could decompose by place value, or you could do constant difference. So make sure you can practice all of those strategies and you know the names of them. If you used a different strategy, that's fine, just make sure you know the name of it and you could explain it. Moving on to this week. So there's different categories of multiplication and division situations, and we can categorize them by type. First, let's just read through some problems and see if they're multiplication or division. So you have a worksheet and it's full of math problems. If you click that blue link in your regular slides, or if you look at your assignments for the week, you'll see it. This is what the worksheet looks like, and it's just full of multiplication or division problems. So make sure you have that worksheet. Another document that you might want is this recording sheet. So the first sheet was full of math problems. You're going to cut them out and then sort them on either side. If you don't have access to a printer, you could do this electronically as well. I just hate for you to have to copy down all those problems. So first sort those as multiplication or division, and then we're going to do some more with them. So pause the video, get that part done. That's the first part of one of your assignments on Canvas as well. So now that we've recorded these, we're going to investigate the different types of problems. So categories of problems. There's a blue link on this as well that has a reference page of these different types of problems. So the first type we're going to talk about is equal groups. It's problems involving sets or groups of objects. So for example, 3 bags with 5 peaches in each bag. That might be solved with repeated addition. Rates is the second type of problem. So rate problems have some sort of rate, like for example, miles per hour, cost per peach, something like that. It's a comparison of quantities using 2 different units. Often rate problems are a type of equal groups problem, but rate problems are easy to identify. The next type is multiplicative comparisons. So this type of problem involves a comparison where one factor is a multiple of another. So for example, John drives 4 times as far as Sally to get to work. If Sally drives 8 miles, how far does John drive? So that's a multiplicative comparison. The next type is area. So we often see or solve problems finding the area of rectangular regions. What distinguishes area problems from other types of multiplication problems is that the total product is literally a different type of unit from the original 2 factors. So the area of a rectangle that's 2 feet by 4 feet is 8 square feet. So the units are different. And the last type is combinations or coordinate pairs. So this type of problem involves finding the number of possible combinations or coordinated pairs using 2 sets. So for example, the number of combinations of entrees and desserts from a menu. So those are the types of problems. Now that you know those types of problems, you should really think about how their problems are similar and how they are different. So now you want to go back to that sorting activity that you started where you have your multiplication and division on opposite sides. Now I want you to label each type of problem. So if it's equal groups, write equal groups. If it's rate, write rate, comparison, and so on. Then, after you label the type of problem, write the number sentence that fits the problem. When you write the number sentence, it's just a math fact. So, for example, 2 times 5 equals 10. But when you do it, put a square around the one that is missing. Still fill in the answer, but we just want to make sure we want to keep track of which one is missing. This is an assignment on campus. Make sure make sure you look through, and there's also where you have to do something with equal groups problems, so don't forget to do that part of the activity. So part of multiplication and division sentences. So now we're really going to start dissecting multiplication and division sentences for their meaning, and you can have the handout with you, or you can take. Alright, so if you look at a multiplication sentence, the first number is the number of groups, the second number is the amount in each group, and then the answer is the product. So this is really important for consistency for students. If you start thinking of that first number as the number of groups or the number of copies, and then the second number is always the amount in each group, it's very helpful to students. Division works a little bit differently, because we can write different division problems. So the total dividend, in that case, is 10 divided by 5, where 5 is the number of groups, and then the quotient is actually the amount in each group. But we could also write the problem where you still have 10 as the total dividend, but this time your divisor is the amount in each group, and then the quotient is still 2. So you'll investigate division problems more next week, but we still need to know the parts of the division sentence. Let's focus on the meaning of multiplication. So if you have someone, an alien, whatever, who has never seen the multiplication symbol, without using the word multiplication or product or any other mathematical word, what would a good working definition of what a multiplication symbol means in the context of this computation? So instead of saying 3 times 5 or 3 multiplied by 5, what idea could we come up with? This is what we were talking about earlier. So A times B could be the number of groups or copies for A, and then the number in each group is B. So 3 times 4 would be 3 groups of 4 items, or 3 copies of 4 items. So on the slide before, we had 3 copies of 5 items. So what's an array? This is a handout that you have. You could click on that blue link, and it has these images on there. It says it's a physical or visual tool, helps students making sense of multiplication computation strategies. So a lot of times students partition an array into smaller or subparts, especially when they know certain facts but not others. Explain what the two students did to determine the product of 6 times 8, and then write equations to show their thinking. So if you were doing this problem, they're still doing 6 times 8, but do you see how they decomposed that 6 into 5 plus 1? And then they multiplied each one by 8. You can think of the distributive property on this problem. On the second one, they decomposed the 8 into 4 times 4. So they're using this double strategy where they might know, oh, 6 times 4 is 24, and I can just do that twice and I'll still get the right answer. So more problems that students struggle with is 7 times 8 equals 56. So I want you to take a minute, draw some arrays like you saw on the previous slide, and write equations how you might decompose the factors and find partial products to remember these facts. So pause the video here and try that. Here's some possible strategies. You could decompose the 5 and 2 for the 7. You could decompose the 8 into 4 and 4. Or you could decompose the just the 7 and multiply it by the 8. Did you have something else? There's lots of ways to do it. We could do multi-digit multiplication with this as well by partitioning. So this is a picture of 5 by 26. Now, you'll want to draw horizontal or vertical lines to divide each array into subparts and see if you can represent your work symbolically and show how you figured out 5 times 26. So pause the video here, try this. These images are on your handout. This is how I did it. So I broke the 26 into 10, 10, and 6 on the first one. So then I just had to do 5 times 10 twice, so I got 50 and 50, and then 5 times 6 for the last one to get 30. On the second array, I knew that 5 times 20 was 100, so I just split it at that last part and had to do the 5 times 6 to get 30. These are the types of story problems that we talked about already. Now we're going to look at some examples. So, using the meaning of multiplication, illustrate the following story problem to show why it can be solved by multiplication. Be sure to write the mathematical expression that you would use. So Sarah bought eggs for her school's egg toss contest. If she bought 5 cartons of eggs that each hold 12 eggs, how many eggs did she buy? Well, this is an equal groups problem. So if you think about how would I write the number sentence that looks like this? Or could I draw a picture? So 5 cartons times 12 eggs per carton is 60 eggs. Remember, the number of groups or copies is first, the size of the group is second. Here's another example. So here's the following story problem. Lindsay's classroom has desks arranged as shown below. Use multiplication to determine the number of desks. So this time the picture is already there for you. You just have to write the number sentence. In this case, it's 4 rows times 6 seats per row is 24 seats. Here's another one. Gabby has 3 pairs of... So Gabby has 4 pair of pants. We'll label them 1, 2, and 3 that coordinate perfectly with 4 different shirts. We'll call them A, B, C, and D. How many different outfits consisting of a pair of pants and a shirt can Gabby make from these clothes? So illustrate the problem, then explain why it can be solved with multiplication. This is called a combination problem, but sometimes it's referred to as a Cartesian product. Here's a drawing for you. So you can see that if you have 3 pants and you have 4 shirts, you get a total of 12 outfits, because you have 4 outfits per 1 pair of pants. All right, here's another example. April's dog weighs 14 pounds. Judy's dog weighs 3 times as much. How much does Judy's dog weigh? It says draw a diagram, illustrate this problem, and use it to explain why it can be solved using multiplication. So this would be a multiplicative comparison problem. So you can see I drew a diagram. I have Judy's dog and I have April's dog, but it takes 3 of Judy's dog to make 3 of April's dog to make Judy's dog. So 3 times 14 pounds is 42 pounds. So this is a good review for times as large as. If there are 5 times as many boys in the classroom, and we know there are 3 boys total, how many girls are in the classroom? So you can see if we represent the one group of 3 as boys, we can make 5 copies of the boys, and that must be the number of girls. So we're doing 5 groups or copies of 3, and we get 15 girls. This is a reminder of those problems and how we can organize them. We can think of an egg carton for equal groups. We can think of classroom desks for an array. We can think of an organized list or a tree diagram for ordered pairs or a Cartesian product. And for multiplicative comparison, we can use those strip diagrams. So let's go over some vocabulary for a multiplication problem. The two numbers being multiplied are the factors, and the answer after the multiplication is called the product. And we can refer to them in any of those ways: the product of 4 and 3, 4 copies of 3, 4 multiplied by 3, and 4 groups of 3. So sometimes we talk about multiplication as accumulated distance. So if you're walking at a rate of 5 miles per hour for 3 hours, how many miles have you walked? This really lends itself to a number line. If you look at this, you can see that we have 3 copies of 5 miles, which would be 15 miles. And we can show it on the number line like that. You also have an assignment that's a 4-door book foldable that's about the different strategies for multiplication. When you're doing your homework, you should practice these strategies. You shouldn't just do it the way you've always done it, because that's what this class is learning these new strategies and techniques to do problems. So here's a strategy. We talked about this just a little bit. So 23 times 14, we could fill in those blanks so we can make sure we can find the product. That is one way to do it. So, and you can see it here visually, right? And we have base 10 blocks on the right-hand side, so you can fill in those blocks and you can find the result. Here's another example. This is from that same book that we talked about last week. So take a look at that. Make sure you can see that decomposition is related to the distributive property, and we can show it in an area model. Notice that we have both of these same things here. So we have 5 times 10 equals 50. Here's our 10 times 5 equals 50. And our 5 times 3 equals 15. Here's our 3 times 5 equals 15. You can use our virtual base 10 blocks to show these products as well. So we put our 2 factors on the outside, and then we're going to build our product right here. So these next few slides are showing us how you fill in those products. And then that's your area. So we have 2 flats, and then we have 4, 8, 11 longs, and then we have 12 units. So we can find the total area. And so there's the total answer added up. So hopefully you could do that with base 10 blocks, writing out each one of those steps. That's it. So week 5, make sure you're really focused on your multiplication strategies and you're starting to put all these pieces together, knowing the vocabulary as well as how to do it, and practice explaining to someone else. Make sure you get all your assignments done on Canvas and let me know if you have any questions. See you next week.